After a hurricane or flood, addressing the state of your electrical conduit and wiring systems is paramount for safety and operational continuity. Contamination from salt water and debris can severely compromise these systems. Cleaning procedures differ slightly for submerged and above-ground conduits. Let's begin with submerged conduits. The initial step is drainage and flushing. Allow the water to drain thoroughly from the conduit system. Following drainage, flush the conduit with clean water. Employ a high-pressure water jet to effectively remove any remaining water, salt deposits, and other contaminants. Chemical cleaning is a crucial next step. Use a non-corrosive cleaning solution to avoid further damage to the conduit. Suitable options include sodium metasilicate or trisodium phosphate. Dilute the chosen solution according to the manufacturer's instructions. Then, using a pump, flush the diluted solution through the conduit system to dissolve and remove stubborn contaminants. Mechanical cleaning might be necessary for removing physical debris. Use a wire brush or a similar tool to manually remove any physical debris adhering to the walls of the conduit. This ensures a clean surface for subsequent inspections and electrical testing. Next, we will discuss above-ground conduits. For above-ground conduits, the process begins with water removal. Disconnect the conduits from all power sources to ensure safety. Open any drainage holes that are present to facilitate water drainage. For cleaning, use a soft brush or rag to carefully remove any surface dirt or debris. It is crucial to avoid using harsh solvents or chemicals that could potentially damage the conduit material. Moving on to wires, insulation inspection is essential. Carefully inspect the insulation of all wires for any signs of damage. Look for cracking, discoloration, or any other anomalies that may indicate compromised insulation. Address corrosion by carefully removing any visible corrosion with a fine grit sandpaper or emery cloth. Avoid using abrasive tools or excessive force, as this can damage the wires. Electrical testing is a critical step. After cleaning and corrosion removal, perform thorough electrical tests on the wires to verify their integrity and safety before restoring power. These tests should include insulation resistance tests and continuity tests to ensure the wires are suitable for use. Some additional recommendations should be taken into consideration. Personal protective equipment, or PPE, is vital. Always wear appropriate personal protective equipment. This includes gloves, safety glasses, and a respirator, especially when working with contaminated conduits and wires. Documenting the cleaning process is extremely important. Keep a detailed record of all cleaning and testing procedures. This documentation serves as evidence of the safety and integrity of the system. For complex systems, it is recommended to consider expert assistance. For large or complex conduit systems, it may be beneficial to consult a qualified electrician or other professional with experience in post-flood electrical system restoration. Remember to consult reference documents like National Fire Protection Association or NFPA 70 Standard for Electrical Safety in the Workplace, Institute of Electrical and Electronics Engineers, or IEE 446 IEE recommended practice for emergency and standby power systems for industrial and commercial applications, and International Electrotechnical Commission or IC 60079.14 Explosive Atmospheres Part 14 Electrical Installations in Hazardous Areas Other than Mines. The NFPA 70E standard addresses electrical safety requirements for employees in the workplace. It provides guidance on safe work practices, including lockout-tagout procedures, arc flash protection, and the use of personal protective equipment when working on or near energized electrical equipment. IEE 446 offers recommended practices for the design, installation, and maintenance of emergency and standby power systems in industrial and commercial facilities. It covers topics such as system reliability, generator sizing, transfer switching, and testing requirements to ensure that critical loads are supplied with power during outages. IEC 60079-14 provides guidance on the design, selection, installation, inspection, and maintenance of electrical installations in hazardous areas where explosive atmospheres may be present. These areas can include locations with flammable gases, vapors, or dust. The standard outlines requirements for equipment protection, wiring methods, and grounding to minimize the risk of ignition and explosion. It is important to know the tools that will be needed. Firstly, a high-pressure water jet is an essential tool for effectively flushing out conduits and removing debris, salt, and contaminants from submerged systems. Secondly, a non-corrosive cleaning solution is crucial for chemically cleaning conduits without causing damage or corrosion. Sodium metasilicate or trisodium phosphate are commonly used options. Thirdly, a pump will be needed to circulate the cleaning solution through the conduit system, ensuring thorough cleaning and removal of contaminants. Fourthly, wire brushes or similar tools are necessary for mechanically removing physical debris and corrosion from the walls of conduits and wires. Fifthly, fine grit sandpaper or emery cloth is used for carefully removing corrosion from wires without damaging the insulation. Next, an insulation resistance tester, also known as a megameter, is used to measure the insulation resistance of wires and cables. This test helps determine if the insulation is intact and provides adequate protection against electrical leakage. Next, a continuity tester is used to verify the continuity of electrical circuits, ensuring that wires and connections are intact and that there are no open circuits. Next, personal protective equipment, or PPE, is essential for protecting workers from potential hazards during the cleaning and testing process. This includes gloves, safety glasses, and a respirator. Next, documentation tools such as a notebook, camera, or digital device are used to record the cleaning and testing procedures, including observations, measurements, and any issues encountered. Finally, reference documents such as NFPA 70E, IEE 446, and IC 60079-14 provide guidance and requirements for electrical safety, emergency power systems, and hazardous area installations, respectively. Some of the key safety considerations in industrial applications include electrical safety. Always disconnect power before starting any cleaning or maintenance work on electrical equipment to prevent electric shock or electrocution. Then there are hazardous materials. Handle cleaning solutions and other chemicals with care, following manufacturer's instructions and using appropriate personal protective equipment to avoid skin contact, inhalation, or ingestion. Next is confined spaces. Be aware of the hazards associated with working in confined spaces, such as limited ventilation, toxic atmospheres, and engulfment hazards. Follow established procedures for confined space entry, including atmospheric testing, ventilation, and rescue planning. Next is fire safety. Ensure that flammable materials are stored properly and that sources of ignition are controlled to prevent fires or explosions. Maintain fire extinguishers and other fire suppression equipment in good working order. There is also lockout-tagout. Implement lockout-tagout procedures to de-energize electrical equipment and prevent accidental energization during maintenance or repair work. Finally, there is personal protective equipment, or PPE. Wear appropriate personal protective equipment, including gloves, safety glasses, and a respirator, to protect against potential hazards such as electrical shock, chemical exposure, and airborne particles. By following these safety recommendations, technicians can minimize the risk of accidents and injuries when cleaning and maintaining conduit and wiring systems in industrial applications. It's important to be aware of common post-flood electrical hazards. Firstly, electrical shock is a significant hazard when working with wet electrical equipment or wiring. Water can conduct electricity and increase the risk of shock or electrocution. Secondly, short circuits can occur when water enters electrical panels, outlets, or equipment, causing a sudden surge of current that can damage equipment, start fires, or cause injury. Next is ground faults, which happen when electricity leaks from a circuit to ground, creating a path for current to flow through unintended conductors. Ground faults can cause equipment malfunctions, electrical shocks, and fires. Another hazard is corrosion, which occurs when metal components of electrical equipment and wiring are exposed to water, leading to rust, oxidation, and deterioration. Corrosion can weaken connections, increase resistance, and cause equipment failure. Next is insulation breakdown. Water can compromise the insulation of wires and cables, reducing their ability to contain electricity and increasing the risk of short circuits, ground faults, and electrical shocks. Finally, there is mold growth. Flooding can create conditions that promote mold growth in electrical equipment and wiring, leading to health hazards, equipment damage, and reduced performance. To prevent these hazards, it's essential to disconnect power, allow equipment to dry thoroughly, inspect for damage, and follow safe work practices when cleaning and restoring electrical systems after a flood. Finally, it's important to adhere to industry best practices for long-term electrical system maintenance. Firstly, there's regular inspection. Conduct regular visual inspections of conduit and wiring systems to identify any signs of damage, corrosion, or deterioration. Pay attention to connections, supports, and enclosures. Secondly, there's preventive maintenance. Implement a preventive maintenance program that includes cleaning, lubrication, and tightening of connections to ensure reliable operation and prevent premature failure. Next is insulation testing. Periodically perform insulation resistance testing on wires and cables to assess the condition of the insulation and identify any signs of degradation or moisture ingress. Another practice is thermal imaging. Use thermal imaging to detect hotspots or areas of excessive heat in electrical equipment, which can indicate loose connections, overloaded circuits, or insulation breakdown. Another practice is load monitoring. Monitor electrical loads and circuits to ensure that they are within their rated capacity and that there are no signs of overloading or imbalance. The final practice is documentation. Maintain accurate records of all inspections, tests, and maintenance activities, including dates, findings, and corrective actions taken. This information can be valuable for tracking trends, identifying recurring problems, and planning future maintenance activities. By following these industry best practices for long-term electrical system maintenance, technicians can help ensure the safety, reliability, and efficiency of electrical systems in industrial applications.